So this Chemisorption instrument we can use for different tests. If we name it, one is like hydrogen TPR to measure the oxygen of your sample. We can use carbon dioxide to calculate the basicity of your material. We can use ammonia TPD to measure the total acidity of your material. We can use oxygen temperature program oxidation of your material using oxygen. And for this one, you just have to change different gas to do your analysis. What kind of analysis you want to do. So there is a turn on power button we have to press before we start anything in this instrument. So press it, this instrument turn on. So to begin with your experiment, you have to turn on this gas bulb, which is for helium, and we have like ammonia and other gas. For this experiment, we will be using helium at the beginning to prep sample. So you will turn off just the tank bulb. So once we turn on the instrument, this meter will show the TCD signal, and we have to turn on the gas to set it adjustable and to stabilize the 0 point of this one, like make it 0. So we will run helium here first. This is the helium gas, and if you look, there is a float which will go up if we raise the flow rate. So we are going to increase the flow rate of this one and all the way up it will hit. So we have to set this one what flow rate we want for this one. So once we turn on the gas, you can see that this is going to change really fast. That means it's changing the gas inside the TCD. That's why it's like reading different reading. Once it gets stabilized with everything in there, only helium, it will become 0. In the meantime, we also want to prepare our sample. So if we take out the sample tube, the gas will not flow through the TCD. But there is an option which is like this bulb. We can turn this one on to sample and bypass. If we do bypass, the sample gas will flow through the bypass tube. That we don't need the sample tube there. So this is here bypass. Now gas is going through the bypass line without going through the tube. To open the sample tube, first of all, we need to take out the thermocouple, which is this here. We will unscrew this one. Just your finger tight and finger will be enough for this one. Take out. So now take this insulator from here. You can keep it anywhere, but I would like to keep it here. And then put your finger just between these two tubes. So I'll explain why. So put your finger here. Try to other hand to take this out. These two out. And then there is one O-ring here and this too. Place your finger here, and because you don't want to drop this one here. If you drop it, it will break here. You have to take this O-ring and this fitting out. Be careful with that and keep that one on the side. I would like to keep it here. You can keep it anywhere, but don't lose it. Second, same thing. Keep it by the side. So now here is your sample tube is ready to clean up and for the new experiment. So bring the tube into the hood to clean it up. There is one metal piece which we will use to take out this quartz and your sample. So put it in here. Try to twist it a little bit so it will grab this quartz and try to keep it in here so that they will not fly. And leave it here. Do the same thing once again. Clean it up. Now still there is some material in here, but you want this one to be clean completely. So now add a small amount of acetone in here. You can rinse it out once or twice. And then add a little more. Use the brush. But by this time be careful that you hold them really gently, not like tightly or something that it can break. And do like a little bit of, and then clean it out. Once again you can put some acetone or isopropanol here and wash it out. Once we wash it, we'll blow some air through this tube, so every solvent and everything will come out. So now you can see it's completely clean, dry inside here. It's ready to run another set of experiments. And we'll prepare our sample using balance. We need to know exact weight of the material we're using here. So we will use one of the cup. You put in here, put this tube in here. This is the cordial I will use, so I put this on here. Close the door. This is the wet tube. Plus 2 is like 2, 3, 2, 6, 2, 0. So once we record the weight here, so take out the tube and also pour wool. Here is the tube and cordial. Keep it on here, be careful with that. And we'll split this cordial in two parts, and like this, and try to make a ball with this cordial. And then we'll put this one on top here, like that, and use one of this glass rod to pull this one down all the way in to the bottom here. Now use around 20 milligram of the sample. You can weight this one here using balance, or you can like roughly add a small amount, like if you know that a material how dense it is. So this is the material I'm going to add here. And you can see that they're just on top of the tube on cordial nicely. And now the second part of the cordial, we'll put it back and use the same glass rod to push it down on all the way down here. So this cordial will make a sandwich with your material here. And now once again you will take the weight of this whole thing, sample and cordial. So this is here. Now record the weight once again. From these two differences, we can know that how much sample we did add in our tube. So our sample preparation is done here. Once our sample is prepared, so we'll put back all those fittings which we take out before, and the O-ring on top of it, and the second one on this side, and also this O-ring here. Still be careful that you don't drop this metal piece on here. This is really heavy, it will break this tube. And then take out here, same way, lock it using your just only 2-finger tie. If you place it right, you don't have to fight with it. If you do have to fight with the setting, that means something is wrong here. You can see nice and tight, nicely fit here. The thermocouple, which we take out first, on top, and which I previously said that you have to be careful, this thermocouple goes just above your sample. So we'll pull it down all the way to your sample here and tight this part using your finger. That's it. And close this one. This furnace is closed now. Take the insulator, which you keep it here. Also put it back, this both part. Change the gas flow from bypass to sample. What we'll do, just move this on back and sample. Now if you look in here, it will go crazy just in a minute because there are some oxygen in the tube. So when we change this flow rate, it will detect the change of gas here. So you can see it's already going up to 6,000 or whatever. After that, it will go down to the zero or like a stable reading since all the gas is going out from the tube. So once this reading came back to a stable reading, which is like 26 or something, so in this gas flow rate, we have to make this one to zero. There are two knobs, two bulbs. We have to tune to make this one zero. So one is called quartz zero, another is like fine zero. So if this one is like more than 10, we have to use quartz to make it around 10, and when it's like less than 10, we have to use fine zero. So it does have a lock. You have to pull it up, so this unlock. Now you have to use this one to make it zero. So if it's positive and you can move it, you can see that it's going down. So once it's like in one digit, you lock it back. Use this fine zero. The same thing, you have to unlock it. Use this one to make it zero and lock it back. So this is the same sample preparation process we will be using for most of our experiments, and this sample preparation we need to done under an inert gas, and in this setup, in this instrument, we are using helium as an inert gas to prepare our sample. Once we set up our sample for the preparation, we have to program the temperature to reach a certain preparation temperature. In this case, for this experiment, we will set 150 degrees Celsius and hold that one for 1 hour, and then it will cool down to room temperature. And this temperature program, we have to use this PID controller here. So this PID does have 4 different buttons here. We use these 4 different buttons to control set our program. This one you can read here is like a page. You press this one, it will open this program list and select this circle, so it will go to the program list, and then go here. This is called ramp per minute. This is how long how many time how long it will stay on that set temperature. This is the segment. This segment 3, that means it does have 3 steps of this program, which we choose the 3 steps, but you can change any to like 6, 7, 8 based on your experiment. So we will choose that one. Go to segment 1. So first segment of this one is set up the type of the setting. So we will ramp this one up to this targeted temperature to 800, but for my experiment here I need 150, so I will set this one to 150. This two button, which is arrow, lower arrow to go down. So we set this one here and press this circle once again to enter. The next one is ramp rate, how fast it will heat the sample. So it's like 10 degrees. The unit is like 10 degrees per minute. And segment 2, it will stay on the temperature. How long? It will stay on the temperature 60 minutes. And after that, in segment 3, it will stop this setting heating up and it will go back to stop. So once we set this up, it will go back to the program list. Now we have it. Press this space to read it out. So we set everything here. So now there is another 2 button here. This button we use to run. So once we press it here, you can see that this run is turned on. That means this program is already running on, and you can see that it's ramping up the temperature. After 1 hour 30 minutes, we came back and we saw the temperature drop down to almost room temperature here. Now we will set up our experiment to read out the sample. When we want to analyze our sample, we have to change the gas from preparation gas to analyzing gas, which is here hydrogen on argon mixture. For this one, we will be running hydrogen TPR, so we will be using hydrogen on argon. In this case, you also have to wait until this whole reading gets stabilized once again, because we change the gas, TCD will read the reading once again. After your experiment, close this tank valve once again. So we turn on this valve, and same thing will happen when you will change the gas to hydrogen to like ammonia or to hydrogen or helium. You turn on that valve, that's it. When we will be running hydrogen TPR in this instrument, we don't want the water to go inside the TCD detector. So what we have to do, we have to prepare a cold trap. So to do that, take out this tube here. If you look here, their inside is already sample prepared cold trap, which is isopropyl alcohol in liquid nitrogen. And to take this one out, it's the same way you did your sample tube out. Pull it up, take out this base from here, put it down here, put your finger or hand like this, take, unscrew this tube fittings here, once you open it, keep it aside like this, and then you prepare your cold trap with isopropyl alcohol and liquid nitrogen. Once you're done preparing sample, since we already have this one prepared, I will not going to show how to do that. So we'll put in here back, simply place your hand like this, you don't want, and then tied it with your finger just like you did with your sample prep. You tied this one here, and then you place this base under your cold trap. So you can see the cold trap tube is half of them is down your solution, and you cover with this insulating here. So if you want, when you want to use this cold trap, you have to change this valve with these 2 different locations. If you select this short path, it will not go through this cold trap, it will go directly to the TCD. If you use long path through cold trap, if you have to select this one back to long path cold trap. So now the gas will go through this and condense all the water here, and dry gas will go to the TCD. In this one, there is this software which is called Chemisorption. You click this one, it will pop up with this window. There are 5 different tabs. We will go to Unit 1. It's a Start Analysis. Select this one. Now it will ask the file name. So we can put the file name here and then click OK. It will ask the if you want to create this one, we will say yes. So it's already created. Next is the amount of sample we add, which we can know from the sample prep. It's here. For my sample, it's like 0.30 gram, and this one asks analysis condition. For this one, which I'm using, you can use different analysis conditions like TPD, carbon dioxide TPD, and hydrogen TPR, and some other procedure here. So you select TPR and set this. So you have this set up already here. You can change this setting as you want to do your analysis, or you can use this default setup. So what I'm going to do, I will change this one for my setup. Like if you want to change this one, like remove this, you select that, hit delete, it will go. You can remove this one too, delete, and if you want to read something here or change something, you go here and say edit, it will pop up here, and you can also go here, and if you want to edit it, you can do this one. It does have different mode of waiting. You can say that after you analyze, it will wait for 30 minutes, or you can say that wait for the operator to come back, so it will keep reading until someone stop it. And you can select anything here. So I will select that wait for operator, and okay. Now here you can, after that what we will do, we select hit, it will go to next step, it will stop recording, and then done, and hit next. It asks what kind of gas we will be using. We will be using hydrogen balanced with argon. Next is operator name and like what kind of analysis we are doing. We already select the TPR analysis condition for whatever we have here. This is name of the operator. You don't have to worry over this part. Now we were here, so it's saying that if we if you hit start, it will start to reading here. So one thing you have to remember, see this reading, which is TCD reading, that's important for our analysis. So it need to be around 0, or like as close to 0 as it possible. So for right now it's around like 0.001, so I will say it's okay for my experiment. Now this is already there. Set up the program here. Now we can go back to setting the temperature program. The same thing once again. So now we will set this program for our analysis condition. Previously we set that one for our sample preparation condition. So to do this one, we go once again this paste program list, enter, and then it will ask ramp unit is per minute, dual unit is per minute, segment is 3, and the first segment 1, which is the ramping type, and what temperature, it says 150, but for my experiment I need 800. So we'll go back to, so temperature is set for 800. Now this is ramp. For my test I need this one to be 5 degrees Celsius per minute, so I will lower it down to 5. So we set the ramp rate of this experiment is 5 degrees per minute. Next segment is what it will do after that. It will stay on this temperature for 60 minutes, and after that it will stop this experiment. In segment 3 it will end the experiment, and then select hit. It will stop. It will go back to the program list. So now it's set. Once again we'll press this 2 button together. It will come back to the front display. Now you can press this to set your experiment. So it's ramping it up. So once the temperature program is done, now we can hit start. It will start the experiment. We'll select continue. It start to reading, and select continue once again. Now we can see how this analysis is been reading. Go here, show result. If we click this one, we will see that live live reading of this sample. So it will go all the way and heat up to 900 or set temperature and stay there, and it will at that time we'll come back and stop this. So after finishing our experiment, that's the TCD signal of this instrument will look like this. For my experiment, it looked like here it's like two step of like reduction of my material, and then at the end of this, you can see there is like 5 spike here. Which what we did, we inject the standard to get the area of this standard sample. So we can use this standard area to calculate the amount of hydrogen it consumed during this process. And then we can save as. It will ask what is the name we want to save this one. So you can put whatever the name of your material, and then click save. So it's save, and you can save it like 3 different formats. One is called report system, another you can save this one to spreadsheet, another is like txt. So whatever you like, you can save this one to txt or excel, anything, and then just hit the save button. As you can see, the temperature of this setup is already came back to the room temperature. So you don't have to worry about temperature or turning on the oven or furnace. It already came back to 0. Now next step is to turn off the gas and also turn off this instrument here, which is in here. You go and press turn off. And after your experiment, don't forget to turn off the bulb. Don't forget to turn off this gas cylinder bulb. Once you set this one up, if you struggle with the instrument, how to use it, and you cannot get your sample done, try to communicate with Dr. Yasek here, or anyone who can operate this one perfectly. You can seek help from that. If you cannot do your experiment by the time you booked, you can cancel that booking time once again and communicate with the authorities that you cannot do your experiment on the time.